exponential equations. As you can see here, 3 to the power of x plus 2 is equal to 1 is an exponential equation. So exponential equations are the equations when the unknown, the variable is on exponent. In that cases, it will be exponential equation, okay? But x times 3 to the power of x is equal to 3 is not an exponential equation. Why? Because here you have the unknown, that you're multiplying the 3 to the power of x with the unknown. So this one is not the exponential equation. Exponential equations are the equations when the variable is on the power, okay? Now we will have different forms of exponential equations and how we are solving them. So the first form, equations of the form a to the power of f of x is equal to a to the power of g of x. What you understand from this? The bases are same, the powers are different. In this case, what you will take, if the bases are same, the powers different, directly you're taking the powers, as you can see here. Since exponential functions are one-to-one, a to the power of f of x is equal to a to the power of g of x means f of x is equal to g of x. If the bases are same, so the powers has to be same. So in this case, directly you are taking the powers as equal, and then you will solve the equation. So write the title and this part. Then I will show you how we are solving them.
Teacher, we have studied this.
We studied a bit, I mean, not too much different examples, but like the introduction.
Yes, probably.
Yes.
Teacher, have 3A studied this?
Oh, yes.
Because I saw it in Stephanie's notebook.
Yes, yes. Because some parts I am not giving to them from logarithm. I didn't give that graph part. I mean, there is no in program in social classes. Directly we gave these parts. And again, not very detailed. But we finish with them the logarithms. We have to finish with you also, but we'll see.
You have 7 lessons back or more.
Yes. We lost lots of time explaining you the complex numbers, the same things again and again. And again, you didn't understand. So now, if you have written this one, let's see how we are solving. You have 2 to the power of 3x is equal to 2 to the power of 9. The bases are same. So because the bases are same, directly we are taking 3x is equal to 9. If 3x is equal to 9, then x will be
3.
So that is the solution. Directly here, it's very easy. Directly, you can find the x. In B, what we have, again, we have the bases same. Powers x plus 9 is equal to 2x minus 15. Then unknowns in one side, knowns in the other side. So it will be, I will take 15.
9 plus 15 is equal to 2x minus x.
Yes.
So we have 24
is equal
to x.
x. So x is equal to 24 in B. In C, look.
3x minus 10.
We, teacher, do it inverse. We will have minus 76 minus 10.
So we will change their places. So I can write this one, 3 over 11 to the power of 3x minus 10 is equal to 3 over 11 to the power of minus 1 to the power of 7x minus 10, yes? Then
Yes.
I need to multiply with minus, so I will have 3x minus 10 is equal to minus 7x plus 10, okay? Because you're multiplying both of them with minus. Now unknowns in one side, knowns in the other side. 3x plus 7x is equal to 10 plus 10. Then
It
10
will be 2.
is equal to 20, x is equal to 2. It's okay? Did you understand?
Yes, yes.
Yes, teacher. This is it.
Okay. Erman is not coming, I think, huh? Besan came
Teacher Elma wasn't here from the first lesson.
from the first lesson.
Yes.
You had the other lessons?
Yes, yes.
Okay.
We won't have only 2 last lessons, only Albanian students.
The history lesson?
Yes, because the teacher is in a seminar.
Okay. Did you finish writing or are you writing?
Yes, teacher.
We finished.
Yes,
teacher.
teacher.
No,
Okay.
teacher, wait.
Okay. Do you have any question, Kibarie, Yona?
So for now, it's okay.
It's okay.
It's okay.
Tamam. Now we have second form. In the second form,
With logarithms.
you don't have the same basis. You don't have in two parts of the equation, the exponential expression. In one, you have the exponential expression a to the power of x is equal to b. Here you have a normal number. In this case, you will have two different solutions. I will show you how. But here, this one, the examples are given all in one form. So here directly, for example, I'm taking a. A is 3 to the power of x minus 1 is equal to 4. Now here I have an exponential form and I need to solve for x. So I will convert this one to logarithmic form. So this one will be x minus 1 is equal to logarithm of 4 to the
Base 3.
3. Yes, because I'm looking for x, I will take minus 1 to the other side. So x will be equal to logarithm of 4 to the base 3 plus 1. If I want, I can leave it like this, or I can continue some more steps to write it more simpler. The one I can write as logarithm 3 to the base 3, because when the argument and base are the same, it is 1. Then x is equal to logarithm of 4 times 3, 12 to the base 3. You can leave it here, or you can continue to write this one. Why I'm showing you these steps? Because in the book, the results, for example, if you are solving the exercises part, in the back of the book, the results will be given like this, not like this, the second way. So not to think that you have mistake. It's not mistake if you will continue to solve it more. Okay.
Can I do the second?
Yes, why not?
It will be 3x, 3 to the power of x plus 2 is equal to 11. So it will be x plus 2 is equal to logarithm of, with base 3, argument 11.
You are solving E, I think, huh?
Oh, yes, teacher.
Okay, it's not problem. It's not problem. So
It will be x squared. Which one, teacher? E or B?
okay, B, let's do the B.
It will be x squared is equal to logarithm with base 2.
Yes. Argument
X will be
to the base 2. Yes.
x will be root of logarithm with base 2 argument 3.
So you can read this one easier, Alexander, as logarithm of 3 to the base 2. Okay, but because it is x squared here you can have plus or minus.
Teacher, can we do 1 over 2? No, we can't. Okay.
No, you don't have to do it.
Yes, yes, we can, teacher.
Yes.
More simple.
Yes. In C, what we'll have?
2x minus 3 is equal to logarithm of -1 with base 3.
But here we need to think firstly, can it be negative, the result?
We
Three.
will change them, teacher. -2x plus 3 is equal to 1.
No. Look, think like this logically. Exponential equations, something to the power of, doesn't matter if it is negative the power, if it is positive, if it is smaller than 1 or greater than 1, the result is always positive. Think a bit. When you're taking 3 to the power of -1, if you have, what it will be? 1/3. Yes?
Yes.
It will be positive in all the cases. 3 to the power of 0. It will be 1. So any exponential function or exponential equation cannot be negative. Okay?
So this is undefined.
Yes, this one is undefined. C is undefined because
So, teacher, if the result is negative, it's undefined.
yes. Function, I couldn't write, cannot be negative.
Sure, we can solve this with complex numbers or not?
No, because look, when you are converting it to the logarithmic form, you have 2x minus 3 is equal to logarithm of -1 to the base 3. What we said in the definition of logarithm, argument cannot be negative.
Cannot be less than 0.
So because of that, you don't have any solution for this. Okay, what about in D, Salman?
In D, teacher, we will write logarithm base 2, 7.
Logarithm of 7 to the base 2. Why are
Yes.
reading from the back part?
Teacher, I'm reading always.
And
like this.
Alexander is also reading the same. Logarithm base 2, argument 7. Logarithm of 7 to the base 2. It's easy. What about E?
Teacher, x plus 2 is equal to
Yes.
logarithm of 11 to the base 3.
Yes.
And then x is equal to logarithm of 11 minus 2 to the base 3.
Yes.
And x is equal to logarithm of 11 to the base 3.
But this,
9.
Oh, no, it's minus.
so here you can leave it like this. Okay. Or
What we can do over.
I can show you one more step, logarithm of 11 to the base 3, because here I have the base 3 minus 2 times logarithm of 3 to the base 3, it will be, yes?
Yes, yes.
Now I can take these two as power of 3, so I will have x is equal to logarithm of 11 to the base 3 minus logarithm of 9 to the base 3. Then because you have the same basis minus between them, you can write this one as logarithm of 11 over 9 to the base 3. Okay? But as I said, for me, also this part is enough as solution. But in some cases in the book, it can be shown like this. So don't think that you have mistake. They are continuing some more steps to write it as a single logarithm.
It's okay, teacher.
Tamam? Did we understand?
Yes, yes,
Yes, teacher.
Okay. Can I continue?
yes.
Yes. No, wait.
Yes, no, wait, okay. While you're writing this one, I wanted to show also one more thing here.
It's okay.
Let me find the book. In some cases, this one can be, for example, a to the power of f of x is equal to b. If you can write b like a to the power of something, also you can solve like the first one. Okay, I will show you now some examples. Okay, there are the third form, then I will show at the end.
Teacher, did you show the second one?
Yes, this was, the previous one was the second one. Second,
Okay.
and now we have the third one. When you have different bases, different powers. What we'll do in this case?
Will equalize to 0.
Will not equalize to 0. We'll have something different. If you have written, why I cannot can scan for file? I cannot download the book. Okay, doesn't matter. In these cases, guys, we'll take the logarithm of both sides. Firstly, I want you to listen, then I will give you time to write, okay? Give your concentration here, focus on here. So 2 to the power of x plus 1 is equal to 3 to the power of x minus 2. Here you have different bases, so I cannot equalize the powers directly. So what I will do, I will take the logarithm of both sides. In these cases, mostly we are using logarithm to the base 10. It's easier for us. So when I will take logarithm of both sides, this one will become logarithm of 2 to the power of x plus 1 is equal to logarithm of 3 to the power of x minus 2. Okay, I'm taking logarithm of both sides. Because this is power, I can take it in front of the logarithm. It will be x plus 1 times logarithm of 2 to the base 10. And this one will become x minus 2 times logarithm of 3. Okay? Now what I will do, I will multiply 1 by 1. And I will get x times logarithm of 2 plus 1 times logarithm of 2 will be logarithm of 2 is equal to here x times logarithm of 3 and minus 2 times logarithm of 3 I will have. Now I will take the unknowns and knowns in one side, which will be how to take this one I will take to this side. It will be 2 times logarithm of 3 plus logarithm of 2 is equal to x times logarithm of 3 minus x times logarithm of 2. Okay? Now here, if I will take 2 as power of 3, it will become logarithm of 3 squared plus logarithm of 2. And here we have x as common. And in the parentheses, I'm writing logarithm of 3 minus logarithm of 2. Now here, what we have, the same basis, addition between them. Can I write this one as logarithm of, this is 9 times 2
Yes.
equal to x times, this is same base.
3 over 2.
Yes, logarithm of 3 over 2 we have. Now this one is because we are looking for, let me write one more step, this one to write logarithm of 18 is equal to x times logarithm of 3 over 2. Am I looking for the x? So I need to divide by logarithm of 3 over 2 and
Here we will have logarithm of argument 18 base 3 over 2.
so it will become logarithm of 18 over logarithm of 3 over 2. If you remember from the properties of logarithm, here you have the same thing, 10.
Yes, that's
So
right.
I
teacher.
can
We
write
have
this one as
argument 18.
logarithm of 18 to the base 3 over 2. So the result is logarithm of 18 to the base 3 over 2. Did you understand?
Yes. Teacher, the only thing I didn't understand is how do we do it to the base 10?
I am choosing the base 10. I am choosing.
We can choose it, okay.
If you want, you can choose another one, but mostly we are choosing base 10 because it's easier. You know, mostly.
Yes, teacher, yes. Because we write also the argument the same as it was, that's why.
Yes, because if you choose some other thing, maybe in some cases it can be more complicated, you know, after a step. But 10 is always easier. Okay. Now write it, then to
Okay, teacher.
the other one. So we have started the third chapter. Some of the parts I skipped, if you can check it from your book, okay?
Okay, teacher.
Sure, can you go down?
Yes. So how I couldn't tell how when your Russian finishes?
Friday, teacher.
Hmm?
On Friday,
Friday.
yes.
So will you come on Friday to school?
No.
Teacher, Friday we will be online also. From Monday we will start
Mhm.
normal. So
Okay. Now I will give you time, but this one is solved in the book. Let's try to solve B if you have finished writing A.
yes, teacher, we finished.
Okay. So let's try to solve B. How it will be? We'll take the logarithm again. Logarithm of 2 to the power of x minus 1 times 5 to the power of x plus 3 is equal to logarithm of 3.
Three.
Now here, because you have multiplication, I can separate it like logarithm of 2 to the power of x minus 1 plus logarithm of 5 to the power of x plus 3 is equal to logarithm of 3. Can I do this one from the properties of logarithm?
Yes, teacher.
Yes. So again, we'll take the powers in front of the logarithm. So it will be x minus 1 times logarithm of 2 plus x plus 3 times logarithm of 5 is equal to logarithm of 3. Then the same thing that we did in A, x times logarithm of 2 minus logarithm of 2 plus x times logarithm of 5 plus 3 times logarithm of 5 is equal to logarithm of 3. Then let's take, let me say, like terms. We have x here, logarithm of 2 plus logarithm of 5 is equal to logarithm of 3 plus logarithm of 2 minus logarithm of, when I will take 3 as power, 5 cube, what will be 5 cube?
125.
125. And here we have x times logarithm of what will have 2 times 5, 10.
10.
Wow, look what we got. Here we
We
have
got 10,
logarithm of
10.
logarithm of 6 over 125, yes? These two multiplication. I'm multiplying 3 times 2, and because here I have subtraction, I'm dividing. Logarithm of 10 to the base 10, what will be?
1.
1. So we have here directly x is equal to logarithm of 6 over 105. Okay? Do you understand?
Yes, teacher, can you go up? No, it's okay.
So teacher, this is the result, right?
Yes, this is the result.
Okay.
Do you have any question here?
No.
The others, girls, Yona, Kibariye?
No, teacher.
It's okay?
Yes.
Yes, teacher.
Okay.
Yes, teacher. It's okay.
Mm. Here you have some more examples about it. We have like 5 minutes. You can start to solve. I will give you time to try to solve by yourself. Then next lesson will continue. Okay?
Okay.